In this video, we're going to go over some more algebra tricks. Let's say we have this question here, and we want to solve for theta. To get rid of theta here, we need to take the sine inverse of both sides. This will cancel the sine on the left, leaving us with theta is equal to sine inverse of root 3 over 2. Then you can go to your calculator and click sine inverse. So as usually for me, it's shift, and then I click sine, which gives me sine inverse. Then I put a bracket, then I put square root 3 divided by 2, close bracket, equals, and I get 60 degrees. Now, if you know your special triangles, obviously you don't have to use your calculator. You can use that instead. And also, if you're in grade 12 or above, then you might have your calculator in radians. If that's the case, your answer would be pi by 3 instead. But we'll deal with that in future videos. In this situation, we want to get x in the top left-hand corner because that's where we want it to end up when we're solving for x. So we can flip the equation like this. Then, to get rid of the 5, we can multiply it diagonally. And we end up with 35 over sine 30. Now we can use our calculator, and I get 70. If you have a question like this, we can diagonally swap the sine 45 and the x. And we get approximately 8.49 in our calculator with a rounded 9. A lot of the time when I'm doing algebra questions, I'm dealing with them more positionally than actually mathematically. So for example, if I have triangle over square equals circle over x, and I want to get x in the top left-hand corner and get everything else on the right-hand side, I can swap the x in the triangle, and I can bring the square by the circle. So x would equal circle times square divided by triangle. The reason why this works is because we're basically just doing a bunch of multiplication to both sides. The first step is we're multiplying x by both sides, and these x's cancel. Then I'm multiplying both sides by square, and these squares cancel. And then I'm dividing both sides by triangle, and these triangles cancel. And then that leaves me with an x on the left, a circle times a square over a triangle, like we have here. But once you've done this many times, it's easier to just do positional swaps instead of just this long cross multiplication, as they call it. Okay, in this situation, we want to solve for x. I'm going to do a diagonal swap of the 1 and the root x. Transfer the sine 60 to the top right. Then to get rid of the square root, I'm going to square both sides. Put that into your calculator and you should get an answer of 3. That's it for this video. Go ahead and try the question on the screen now for homework.